Thanks, Emily. Thank you so much. Okay. So today we are thrilled to have Mahdi here with us again. As a lecturer, he will enlighten us on using class platform tools to manipulate data for informed decision making. This marvelous machine learning lecture is the one we all have been eagerly waiting to learn, and I'm just as excited as you are to learn more from Mahdi. Without further ado, I hand over the mic and screen to you, please. We are eager to learn more from you. Can you share?
Okay, thank you for the introduction. What you guys want to share? You're asking me to do that? Okay, great.
If it's possible. Yeah, thank you.
Yeah, why not? Let me just check out. And I'm so happy to be with you guys today. And unlike any other lectures about using machine learning, I planned this session to talk about hands-on projects instead of going through technical or general ideas. We're going to talk a little bit about what are these high qualified algorithm just in 5 to 7 minutes, so we can make sure that we feel what is actually behind the scene, and then we're going through the actual hands-on project we have, so you can get the gist and follow the stream of thought that we are trying to add up to our research projects. And I want to make sure to have this guarantee behind any second that we're going to share about this knowledge together, that you can find the exact notion that when it comes to solve a complex problem, what should we do? So let me share my screen and take on this to the high road. All right, where is it? Come on. And all right, do you have it? It's a complex big data. Okay, great. We all are architects, designers, engineers, and real world problems. They are complex. They are from different resources. As I mentioned, the first there is a hash that we should go through to find out the relations between different factors and parameters. These are the things that we talked earlier at the first session. But what are the attributes of that hatch that we need to go through anyway? There are connections and proportions between parameters. For instance, this image is related to a complex big data. It's not important where's the resources, but I mean, for instance, we talked about designing an element with these kind of connections and proportions from factors and parameters. So imagine this is a model we're going to go through, and there's no way we can find out how to solve this complex problem, but we can find the patterns, we can find the paradigms. These are related as a summary to what we discussed earlier. How we can do this, I mentioned the high qualified algorithms are there, so we can follow this kind of idea, relying on them. And in order to do that, today we're going to talk about machine learning algorithm as just one branch of high qualified ones to go through design engineering or fabrication procedures to what? To optimize the process. No matter what is it related to, like a design process that we have our mind and hand on a sketch to define something related to those parameters, or it is or it is related to the engineering part with sensors, parameters, experimental models, prototypes, everything related to that, or even to fabrication, or in our case, which is related to building industry, we have the construction part of project. We need to think about it. Anytime we start to design something, we need to think about how we can construct it. So the systems and techniques of fabricating some elements gets, really important, and we need to follow those specific patterns of ideas that make our elements, make our design to be, constructible. So in these three different branches, or better say AEC, architecture, engineering, and construction, we can apply machine learning algorithm to define, or better say, to find or recognize the patterns of solutions. So we have these kind of sections so far. A complex problem, which includes so many parameters with different proportions. When we have an algorithm to recognize the paradigms inside those parameters, and we need to have an output which gives us the idea or the chance to make an informed decision. Now, follow this kind of segments: the data, the algorithm, and the informed decision. All of them are based on those connections and proportion through our data. So let's just dive in and check out what is machine learning algorithm and what they suggest us. Although there are different levels when we talk about AI or whatever, machine learning algorithm is just a specific part of the whole cloud of thought. And just so you know, we have different scenarios, different algorithms with different levels inside that cloud, but we're not going to cover them this session. However, if you had any question, like for deep learning models or whatever, you can ask me or ask the team after the workshop. We're going to be so glad if anything came up, because this is related to the stream or research. So we can use your ideas, your thoughts, your talents, your skills, and add you as a member to one of our research streams so we can work together. This is what I mentioned at the first session, and I'm accentuating this again because the whole workshop's output for us as our data team is finding you, okay? So let's turn back to our subject, which is machine learning algorithm. In general, machine learning algorithms are divided to three branches: unsupervised learning, supervised learning, and reinforcement learning. And on each section, on each subsection, we have different scenarios, we have different, kind of function each algorithm, and each of them can do some stuff for us. I'm trying to not to talk technically, but to transfer the general idea behind the whole system. So if I as a designer, as an architect, want to follow a paradigm inside the parameters, I can implement one of these kind of machine learning algorithm based on two different situations. Kind of I'm trying to work on the scenario or the strategy that algorithm gives us, or I better say the data structure that the algorithm is based on, which needs you to dive in through them and read about to choose wisely which algorithm is better for my data structure. And just in a general idea, supervised learning is related to the those algorithms, and we give the algorithm some hints. So if you want to follow, or better say, to find some paradigm, some pattern inside the parameters or inside the iterations I have, these are your hints. Follow these and check out which iteration has these kind of features, okay? This is supervised learning. And unsupervised learning is related to those algorithms that we apply through the data without any hints. Those hints are, titled the labels on our data. For instance, each iteration in design process in architecture has different attributes, different properties, and each of those attributes are just work like a label. Okay, so if I want to follow a specific iteration, some specific feature inside the design process, I need to sort out, or better say, have a list related to the iteration based on these, labels. If I want to make it, general example, you have, better say, I'm pretty sure that you have already seen so many machine learning algorithms or AI platforms that recognize different kinds of dogs. So those paradigms that these algorithms are, or better say, follow all the time, are related to the geometry of the location or situation of the eyes and nose and the geometry of the face of the dog. So in different types and different kinds, those algorithms follow these kind of attributes or labels to recognize which type of dog this is. So it's the same process in what we can actually apply through our. If I want to recognize, for instance, a column with different attributes like the shape or the grammar of the shape, the material, physical, mechanical features, every related thing into architecture that we apply to our design process can actually help the algorithm to find out that specific element through tons of data. And that's what we call unsupervised learning. Without any label, without any hints, that algorithm tries itself to find out the paradigms, find out the patterns among the big data that we have. This third part is reinforcement learning, which is related to something that the algorithm would start to follow, but find something related to what we want. We can have some sort of, a reward. Okay, you're doing good, so go through that path. If you want to, have more rewards. So, for instance, robot navigation is something that is based on reinforcement learning, and it's obvious based on those rewards. If a robot find a path that it gets through something, for instance, I don't know, maybe the Pfizerium algorithm would find a food, it can reinforce that specific path with, twice as value that it has to follow the food within the same path again and again. So in that case, we call the algorithm reinforcement learning. Now let's get along with what we have through these kind of stuff that recently has raised up. In different scenarios, from the sketches to the detailed design, the architecture, and of course, constructing a building. And nowadays, we have circular buildings, for example. Just search about read about what is circular building. We can apply these algorithms for different decision-making stages that we have. We want to optimize our design process. We want to control the material waste. We want to, simulate something related to the physical models. All of these aspects, or all of these segmentation of the design to fabrication process have tons of data, and we can go through them with some sort of shield. That shield is high qualified algorithm. And if you find out how to use them related to the data structure, the data type, and of course, the decision you're about to, make based on an informed one, or based on some information, you can use these kind of algorithms. So I'm going to walk you through this kind of stuff with some related research projects that we have. So based on the freeform structure you design as the workflows and during these days that we were together. For instance, just think about it. How can I make the Physaриum to work more smarter? How can I define the food in a more intelligent way? How can I weave, or better to say, to integrate the structural attributes? Remember the hints and labels? How can I integrate those structural attributes to the way that Physaриum grows? And these are the aspects that you can think about for the next stage. The next stage is using machine learning algorithm, or even more higher qualified algorithms, and to solve the problem more intelligent. We're trying to follow the stream in our research projects, and I'm going to present to you some of them. We will have 3 different projects for you. High-rise building curvature hack, which is related to those who are interested in sustainable design. I'm not, but I was in charge of the data manipulation. And of course, the second one is about managing data through so I mentioned cross-learning, but it was related to cross-platform. It's not cross-learning. Cross-learning is another project I'm working on. That was a rookie mistake. Okay, the third one is shadow stretch coefficient, which Behnaz and I and one of other members are working at the moment. And yeah, I forgot to mention the GH2D here. We're gonna need to talk with that. Okay, let me start with the high-rise building, the curvature hack, so you can follow what I'm talking about. Okay, I need to change the screen. Let me go for it for a second. Okay, that's one. All right. I think you have my screen now.
Yes, we have.
All right, thank you. Okay, this is the project I'm trying to represent. But before going through that, if you have any experience in designing based on environmental issues, you probably know about ladybug and honeybee and how we can add them through the algorithm to define a form finding related to those environmental aspects. So in this project, we had a big question. And the question was, if we want to have a high-rise building and we want to find the perfect form for it through the segmentation of floors, as you can see, this is just a loft in z-axis, but it has different, profile in xy plane, different height. So the shape is not Euclidean, or it's not, it's just a freeform on each side. So let me show you one specific image here. The big question in this image is if I want to have the form of this building, it's a top view, by the way, and I want to manage the amount of solar incident that is going to occur through different sides of the high-rise building. How can I, go through that? And if I want to go further with planning some photovoltaic panels on it, where are the locations? So in that case, yeah, I know the designing procedure of a high-rise building has so many other levels, but in this case, this is just one layer of attributes to be added through the whole procedure of designing a high-rise. In this case, I try to use mathematical equations to ask the algorithm to integrate the environmental, attributes, which in this case is the solar incident. You can see the yeah, the unit here, kilowatt hour per square meter. And based on that, it tries to check out different profiles of the height of the building that a specific, solar gain or solar incident. So think of it as a high-rise that is based in Malaysia. In that case, that location, we need to reduce the amount of east and west side and manage the whole, solar incident through just one side to control it with some shading. This is the whole design problem, right? So if you notice, we have some sort of a smart rotation through those profiles. And now you can see the east and west side has kind of, minimum amount as much as it can. I know the north side, yeah, it's not facing to the solar, or better say solar sun position or whatever, but east and west also has some sort of rotation to manage the whole thing. So let me just open the algorithm, so you can follow the whole thing. All right, before going through that, you remember I mentioned something about data in different segments of using a machine learning algorithm. The data was the only one thing that we needed to follow: the type of it, the amount of it, the accuracy of it, which is highly important when it comes to training a model, training a machine. The accuracy of data is highly important. So we need a specific framework to make sure that data is accurate. And of course, the outputs, which gives us the informed decision in designing an elements in architecture. So in that case, to make sure every aspect of it, I use the curvature kappa coefficient to check out the profile of the height. So what are those specific, let me show you, profile that I'm talking about a lot. Here you can see each of them. Yeah, there are 3 of them here. One is at the bottom, the second one is in the middle, and the third one is at the top. So by checking out the curvature of the curve that's generate each profile, I can make sure that in every profile, in every segment or floors, the building has the capability to check its rotation in that specific profile to the solar amount that is being, occurred on that specific site. So this is the first layer of information, and you can follow these kind of stuff like related to the curvature calculations. And I have some resources for you regarding that. You can check out these formulas. The number 6, if you wanted to follow this, I can share it, don't worry. Number 6, the equation number 6 is related to the parametric curve in XY plane. The absolute curvature K is defined as the follows. This is related, one of the amazing resources of this project. And we define this through this equation. And based on that, we can have the curvature for each side. Okay, so think about just this profile on the ground by checking out the specific points on the edges and on the corners, or the vertex of our curve within this profile on the ground. I can manage the whole thing with just some simple equation based on the curvature amount. So let me change this so you can find out how this works. For instance, I hope it doesn't take that much of calculation process. As you can see, the more this profile gets closer to a circle, the curvature is gonna be less and now we have a profile just related to a circle. So by default, we have this notion, all right, if I can build this high-rise building related to just one circle, I may have managed the amount of distribution of the solar incidence in every size, every aspect. But the algorithm gives us something else. And now by turning this to 2, we can find out, okay, it is capable of changing the curvature on each side. So there are different possibilities to be calculated under the solar incident calculation. So I used Ladybug here to check out different iterations, and you can see this is one of our iterations. It shows us the distribution of the solar incidence. So if you follow the algorithm, you can find out on each side. I'm trying to calculate the curvature too. Okay, the first layer was related to these profiles on the ground. The second layer, however, is something else. Let me show you one specific example. This building is based on a high curvature, and you can see these, circles. Some of them are related to the XY planes and calculates the curvature of our profiles through different floors. But the other, the pink ones here, are related to each of convex and concave of the whole building, like how much concave or convex the north facade, the north side would get, and the rest also follow the same procedure. So by that attitudes, I can manage my whole building to be capable to get convex and concave in each side, whether the attribution is related to the z-axis or in xy plane. So the algorithm can generate different formats of my building, and if I record the data related to them, I can have big data, for instance, like, I don't know, 10,000 iterations based on different capabilities with different solar incident that is recorded. I may have the first stage of machine learning, which is, generating a big data. And now, for the next stage, we can have a specific sort of machine learning algorithm to go through these data and follow the paradigms of the better to say, of the more integrated version of our building related to what we want. We are the designers. We need to give the algorithm some hints in this case. So based on supervised learning, as we talked earlier, we can have the whole building toward a broken down of a complex to something simplified by this algorithm. So this is what machine learning can offer us as designers. So think about this. This project is, by the way, is a huge one. It's related to 2 of my colleagues, Professor Kam Al-Obeidi from Sheffield University and Maulud Saifi from UTS in Malaysia. She's, by the way, heading to Germany, but we try to have the whole procedure under control and to check out, let me open up some sort of, if I find it. The whole thing is based on this flow chart. You can follow the definitions we talked earlier, the analysis, that is how we record the data, how we manage this stuff through curvature, and how we define the attributes of the environmental properties, and the result in the funding that we can expect through the whole algorithm. So this is the output. Let me open one of the other folders. Okay, where is it? Ah, this is the one. All right. In this poster, you can find out the different iterations of our buildings and some sort of, clustering based on different features. And each of these kind of sets has different attributes through the elements that we're trying to design related to environmental considerations. And you remember this popular diagram that I always refer to. We're going to have a connection between parameters and factors, and of course, the data and the next stage of which is related to design qualification that we are going to follow. And based on machine learning algorithm, we are going to find a functional paradigm through the whole design process. This one is open for future collaborations. If any one of you guys were interested, just where to find us, and you can give us some hints, I don't know, ideas, anything that come to your mind, or even going through an upgraded version or whatever. We actually welcome you for collaborating on this. Okay, do you have any question related to this one? I'm gonna go through the next item. Behnaz, how much time do I have?
Thank you for that lecture. We in 50 minutes is left on this session. In this part of the session, I don't see any question in the chat, but that was an eye-opening. It was really interesting, and that is actually what I really eager to learn more about. I know based on the survey we took when we start the workshop, lots of our participants also are interested in this topics. Thank you so much for showing us this amazing keywords with actual project that happening in the in reality, not just in just as a concept. It was really interesting.
Okay,
I
thank you. But you were talking some sort of, okay, we're gonna goodbye to you, Mahdi. We have some sort of
No,
other
no,
stuff
no.
to do.
I'm just, I was just really thrilled.
All right,
Just
great.
got carried away a little bit. I still don't see any question. If you want
All right.
to go on, please.
Okay, great. Maybe after, covering the whole thing, we can turn our way back. All right, guys, this one was related to an undergoing project. The next is based upon a very different version of Rhino Open here. This is much more related to the one that you follow through the whole workshop. Maybe I can give you some specific ideas to the next stage. We, by the way, ourselves at Ardena are going to develop the whole stream of the framework, the workflow, and the next stage for us is applying machine learning, of course, to set up two different gap here. The first gap for us is to get rid of nuclei because we need a more, fast and generative procedure for the Pfizeria. This is the first stage that you can collaborate within this project. And the second stage is if you have any kind of experience, if you are interested in using machine learning or other stuff related to, what AI suggests us, we can start to rearrange the rest of this project based on your ideas and your thoughts and get along with it for the next stage. So the next stage is clear for us, and we're trying to make this integration either the face-to-face which, by the way, you experienced through the recent days, out of the face-to-face into an automatic or automated, single procedure. So this is how we started to develop something that you experienced through the whole workshop. And I mentioned about the procedure at the first session, but let's just walk through this 1 and 2 so you can find what exactly is behind the scene. So the question here for us was which type or which image was a better choice for us. For instance, this is the iteration number 66. The gene code is 1, which is related to some specific image. And the whole idea is based on an image processing, which, by the way, is really painful to follow because it takes a lot of time to calculate. And the rest is related to what Karimba gives us, like the displacement of the structure, which is 16 centimeters, the elastic energy on each element, the mass in kilogram, and the element diameter and element thickness are 2 attributes. Now that you know how to define some inputs for a high qualified algorithm, we talked about the labels, the hints and everything, or data types, you can now check out this kind of block of information related to this specific model. So if I start to record the data based on the same pattern of recording data, but in a lot more iterations, I actually find myself the feeding type or feeding list of information or data for my machine learning algorithm. Okay, the question was the same as I mentioned earlier. Which type, or better say, which image or which pattern of nature perfects the best, or better say, the more improved for our freeform structure, which is static. It's not a dynamic freeform. Okay, that's another level of consideration. We're not gonna go through that part. It's partly huge. Okay. We use Python and we use different Python packages to check out our iterations performance. And we define them through, the recorded data, which comprised 2,438 iterations, which is not quite enough for having an accurate model. The next project comprises, I think, 15,000 iterations. You're going to find out how the accuracy of the data is really important and how it actually guarantees the model to be trained in a perfect way. So I defined other attributes for my model here, the element diameter, so I can check out which element could actually follow the best cross section. And then I sorted them out based on mass in kilogram and elastic energy. We talked about them earlier. I'm going to scroll this down because we went through this at the first session, but this, the diagram here is highly important. This is another set of, help that we can get through our decision-making, but based on machine learning algorithm. There is a specific part that we can apply ML algorithm, like to categorize or cluster our data into different stages, different levels of performance. And in this case, I asked k-means clustering, which is one of the specific algorithm, to categorize or to cluster our data into different stages, and it gave me the iterations on that specific cluster that I want. Yeah, it's typical that your tongue doesn't revolve properly. Ahmed the other day said something. I want to screen my share, and now I got actually myself into that part. Don't worry, these are the jokes through every workshop it happens. And after the clustering process, I asked the algorithm to give me a CSV file related to the selected ones and asked it to save this for me on our folder. This one, no, the iterators for recalling CSV. And in this one, I can find those iterations that are related to the feature that I want. All right. So inside the algorithm, no, let me just show these kind of stuff a little bit. Okay, inside this one, I could be able to recall those, iterations. Yeah, I know I ran this before, but let's just go through it because it's now related to how we can apply machine learning afterwards. So if I want to recall, for instance, the number 32, the whole iteration or block of data or information would be updated, and the model itself also updated automatically. So the algorithm works, and now I only need to put this under the recording part to have that specific data for the next stage, which is related to train a model, whether it's related to applying a high qualified ML or a deep learning model. The training procedure can actually be, reliable within this algorithm. So this one gives us the opportunity to record our data, to feed a model to be trained based on the performance that Karamba calculates and the geometry that we are generating based on nature. And imagine at this moment, I only have just 10 images from nature, okay, in different branch. Each of them has 50 to 50 pixel of data in RGB codes. And it works like this to apply, every specific branch, which represents one gene code. This one is number 6. Then you can check here. It's automatically updated based on the Python code that we had already. And if I have thousands of images, or I don't know, 5,000 of them, and the algorithm gets at the rich point of data, so I can find out within this specific freeform structure which of nature would work the best. Although I never say the best version of design could follow as an output of an algorithm. We can, by the way, going through the better one. So this procedure gives us the opportunity to record the data and going through applying machine learning. All right, the next project is related to having recorded data. I choose these kind of projects so you can find out the main gap that we have as architects and designers, which is developing a database. It's not related to those algorithms. Those algorithms are out there, and you can use them really easy. But you need to know the general knowledge to select the best based on the data structure and the data type that we talked earlier. However, the main problem for us as the users of AI recent achievements is to develop something like this, so it can give us the data. All right, the gap of data is the main problem. You shouldn't be worried about the algorithms. They are already written and they are free to use. Just think about the workflow that is related to solve a complex problem. So that's the big question for architects. And so many students come to me and ask, okay, what kind of algorithm I should learn and what kind of course I should get. There are plenty out there, but the main consideration, main concern is not the algorithm and learning how to use machine learning. The main concern is how to develop and generate data. So that is why I emphasize on these two before going through the trained one. Okay, the other projects is related to a more simpler question, but with the trained model related to linear regression, which is a specific, machine learning algorithm. I'm going to talk about it. Okay, what was the big question here? imagine we try to design a residential complex, and we need to define the perfect match or distance between the first block and the back blocks. And if I want to match the distance based on the height and the shadow stretch of the first block, what should I do? And how I can define this distance between the back blocks related to the front block. I know it's kind of a bit of an imaginary one. You may ask how you sort these kind of stuff like this. They are based on the shadow stretch in different hours throughout the day, and those days are related to a specific, time frame in summer and in winter. And in that case, I can find out the minimum amount of shadow stretch and the maximum amount of shadow stretch if the building has been located on the north sphere of the Earth. Some position would be like this. So the shadow would be the north side of the building. So by tracking them and recording the data related to that, this is the algorithm that gives us the opportunity to record the data related to shadow, hourly shadow percent and hourly distance related to each iteration that we have. And these are the open parameters that gives us the attributes for the building block, for the block of information related to this specific design that we have. For instance, this one has 10 floors. The required shadow percent is 100. And the desired shadow is, for instance, 30%. I mean, the desired shadow percent is related to the one that is going through the back blocks here. Based on the shadow stretch of this one, 30% of the back blocks would be under the shadow. Okay, so these are the attributes that I give to the algorithm, and then I try to run it through. I'll just open this one. Where is the recorded data, so you can find out how many iterations that we had before going through training the model. These are the recorded ones. On each side, you can check out the richness of this, the distance from 9 to 15, 9 a.m. to 3 p.m. And the shadow stretch, again, also in another list, the average distance between the blocks and the shadow percent average, desirable shadow percent, variance, which is related to the data we have for different iteration or different kinds of the specific number of floors in 3 different, cities in Iran, Isfahan, Tabriz, and Bandar Abbas, and with different number of floors. And also I track the standard deviation between those, average distances. So you can check, there are 15,000 of iterations here. So I could train an accurate model based on that. What does it mean? I'm going to give you some sort of a sneak peek to make an impression. Now you can find it within this specific iteration. I have Bandar Abbas as one city, and all of the data related to weather data, EPW file has been loaded to Ladybug again. And the number of floor, the standard deviation, variant, desirable shadow percent average, and average distance, which I want to ask machine learning algorithm to calculate this for me without any further calculations. I mean, I trained a model, I trained an algorithm here, and based on giving out these kind of data without any ladybug or grasshopper or anything else, I asked the algorithm, okay, what is the average distance for me for my design? Okay, this is the case. We're going to the whole process together. So Where is this data lore? Oh, okay. Here's the one. I hope it works without VPN. Data lore is from JetBrains. JetBrains is an IDE or integrated, what was it, dynamic environment or something like that for using different programming languages in just one specific environment and defining virtual machines. So you can find it easily, and it gives you so many amazing stuff to share your codes, to share your notebooks. I think it doesn't work without a VPN. Let me just refresh it for a bit. Yeah. So that's a common happening procedure when you live in Iran. Nice. Hey guys, just give me a second. Maybe I lose my connection. Then I'm going to get back. Hey, I'm back from somewhere in Netherlands. Okay, I need to share my screen again. Well, you should have my screen now. Good. All right, this is how I went through the whole stuff. Since we're not gonna talk technically, yeah, I'm gonna run these bunch of codes so you can find out the data we have. For instance, if I ask this to visualize my data and the statistics, you can find that this city, which has these index from 0 to 2, and the distribution of my data, you can see we have different samples from each city. And we have different, data from number of floors. And of course, the standard deviation variance is not important in this statistics, but the desirable shadow percent is from 0 to 100. That gives us a good distribution through different possibilities through the design process. Okay, so the rest is also readable like that, but I'm going to go through the parts that gives us the accuracy of our model, which is relatively 92%. It means that if you ask a question throughout this algorithm, it may only have 8% of a failure to what gives you as a solution or as a responding. So this is the distribution of our data throughout this scatter plot. And if you imagine a linear a line from 0 to kind of a diameter line from here to here, you can find out, all right, these iterations that we have, 15,000, are giving out something in similar. The distribution is not that wide or scattered all over the place. And yeah, it gives us the idea that the model is reliable. And the next stage is also related to another metrics that we can check out the accuracy of our model, but this is the actual part I wanted to talk to you guys. So let's just compare it with what we had earlier, okay? So the city is Bandar Abbas, as we have here. All right, can see it. And the number of floors is 10. The standard deviation is 9.47. I have them here sorted out. And all of them are related to the same process the Grasshopper has given us, okay? And now the average distance of design of the back blocks, back buildings is 32.8 based on what Grasshopper has calculated. And this algorithm, without Ladybug, without anything, just by being trained by a data, gives us 32.79. And that's really accurate. And if I have something like this, let's think about the reverse engineering, okay? So I have a model that is trained to give us the distance that we should apply throughout the design process of building together a complex or residential complex. And now I can use this in a small specific web-based application or something like that. The implementation is, you know, huge. And think of it as a sample. That's machine learning algorithm can actually be trained by your data. And you are the designers, you are the architects. People ask me, okay, if AI comes up, what should we do? You should do your job. And your job is to feeding AI or feeding machine learning algorithm with true data, with accurate data. And no one else can actually go through that part but you. Okay, so this is a big question. Just put it aside. But this project has now a trained model. And the data came out of the Grasshopper. And now we can apply it on any, you know, design process inside those three cities. Okay, if I want to apply it to different cities, I need another data, another EPW part, or something related to that. But you experienced this third stage here, like having a model to generate different iterations and different data, having an algorithm, and use the algorithm for your design process. An informed decision without Ladybug, without anything, without any further calculation, but based on what machine learning gives us. Okay, that was, you know, the end of my lecture. Just let me know if you had any questions.
Thanks a million. That was amazing.
Thank you. Thank you. Yeah, I hope you find it interesting and, of course, an open door to go through this without any hesitation. Because, you know, when I wanted to start thinking about or going through learning this stuff, that was, you know, some moments that I couldn't find any reliable resources because the real problem is the databases and the workflows, and there were nothing. And we just started to learn with different courses that were not necessary at all. And now I hope it's like find the three sections in your mind and follow the exact need you have, or better say, something that you need to use these kind of amazing recent achievements.
Sure. If anyone has any question, please don't hesitate to ask. Someone asked a question. Victor says, what's the main difference between a platform you have shown and Jupyter Notebook?
Okay, let me just give you an example. There is no, you know, such differences, but in, I think the integration of JetBrains and the data lore is much more related to collaborative works. And when, for instance, a project is related to a team, JetBrains has developed something based on web applications and its own servers, and you can add different members and you can, work on the same notebook. I know that Jupyter gives you this opportunity too, but JetBrains platform is much more, user friendly. Yeah, exactly.
If I wanted to do this in Google Colab, was it possible to do that in Google Colab?
Of course. Yeah, that's another platform that does the same.
Yeah. So I was I wasn't present in the middle of a part, so I'm asking you a question about when you show everything, was it to connected your notebook was connected to the grasshopper at the same time?
Okay, no, it wasn't connected. That's actually a good question, by the way. We have other people that made this connection as a live link. I wish I could, ask them, but they're not here at the moment. Maybe I can ask them how they did that. But as I remember, they've defined a Jupyter notebook file inside one specific folder on the hard drive, and the reading and writing was totally connected between Jupyter and the Grasshopper. The Grasshopper was listening to the change of data through the hard drive, and the Jupyter Notebook, on the other hand, was updating that specific file name. Okay, and once it's updated, the Grasshopper refreshed all over again, and the data from input and output will be connected. In our cases, there were nothing like that, but we had some experiences about this. It's another project relate. I think the title is Cross-Disciplinary by Ilham and Atrin and Hengame. There are 3 people on our research team.
That's really impressive, and I know it's very complicated. I mean, they're really tough guy who actually connected Grasshopper into the Jupyter or Colab in any system. And I was trying to find some program. I mean, I don't know if someone developed it yet, or I was trying to work in that the generative adversarial network or ML DL, this kind of program, if we could take from Colab to Grasshopper interface. I mean, Grasshopper is all about Python. So if somehow, I don't know if you know this or if you have this resource to connect this Colab thing into the Grasshopper interface, then I think we architect could easily do that. I'm trying to, but it is always stuck somewhere in the Google Colab or Jupyter notebook, so Grasshopper is more visualized, so it would be easier for us, but we had to go through the other interface, and it's really tough to work, I mean, initially. So if you have any solution for that, or if you have something like that, maybe you could share the resource so that I can study and develop it. I don't know. So I was wondering if you did work something like on it. Could you please share your experience on it?
Okay, great. Yeah, I wrote this down. Yeah, I will, ask those people I mentioned, their names, to check out the references or resources, and we can talk about this after the workshop. But that idea is really, great to follow. I will update you, Shazad.
Thank you so much. And I will share something with you later. Anyway,
Of course,
related to this.
Any kind of collaboration. This is what these workshops are about.
Thank you so much.
Is there any other question? Otherwise, we can go on and take our break. Okay, I guess now we have, if we go for 50 minutes, we can go back in 17 in GMT time.
Okay, good.
Yes, it's Jim.
Thanks again. That was really marvelous. Thank you so much.
Oh, thank you. Thank you. Okay, see you guys.
Back in
Thank you.
50 minutes.
Yes, thank you. Bye-bye.
Hello again, everyone. Hello, dear Mehdad. Hi. Hopefully, everyone gonna be back in a few seconds. So, today, one more time, Ahmed will kindly go through the workflow one last time, so we can go through everything so far we talked about. And after that, I will present to you a presentation layout I created for your final presentation. And after that, we will talk about your ideas and your work so far, just like yesterday. So without further ado, dear Ahmad, mic is yours.
Hey, Behnaz. Hello, everyone. Did not unmute myself during this session because that was there and it's a bit hard to control. Okay, I will go through the file again, and I will share the workflow again with you, and we go step by step. We'll go step by step together to review and recap everything that we need to have a better output for this workshop. Okay, as you know, I make it in a 9-step, but it's not important that I will name the step, but I will go one by one, and you can follow me. And if you think that you have missed anything during this 3 sessions, you can be with me to review everything again. Okay, just let me. We always start with the first surface and the surface that we need for the main structure, and to applying the Gera on it. I name it. You have my screen, I think yes. We have the Gera surface that I modeled it here. This surface is 10 meter by 10 meter. You can see it, yeah, 10 meter by 10 meter, and the units. Make sure that your unit is on meter, because everything based on meter is Karamba, Ladybug, and even Nuclei. And if you change the unit, you should change a lot of settings there. Okay, after defining the surface to this, we can go for what we should done to have this surface that is with Gera. Please pay attention to this legend that Behnaz has prepared for us. When we have see something gray, it is something that we need to define it from the Rhino file that we have. And when we have something in white, it's related to something that we can change the number. And other things that we have here, for example, the blue one, yeah, the dark blue for gray, and something like cyan or Persian blue is for Karamba. Environments like purple, and Physarum is gonna be pink. For example, once we are seeing this, we know that there is something that's related to Karamba. Okay, we can see, for example, here, yeah, here we have is there that we have our first force flow that's we're gonna make everything and make every parameters of the graph based on this force flow. The second part that we need to know, I will put this for another time. And for the second step, I think it's important to choose your grid. The grid, the bank of grid that we have here, you can see that different grid that we have here that Behnaz has prepared earlier. You have all of them, and you can change the grid and the number of the modules that you need. For example, you can see that here we have 5 and 6 modules that you can see here. For example, oh, it's not the same one because we have 6 and 5 modules, and every one of these girls that you want to choose. After you choose that, we can, for example, we want to change one of these curves. We can open it and choose which curves we need to have. For example, these curves or these curves. If we need anyone, we can add it here or disconnect it. For example, in this case, I do not. Well, I want to add this, for example, this line to my URL. I need to add this curve, and we can see that the output have the lines that we need there. After we're choosing our gira, for example, here in this case, just we should make sure that this surface is the same surface that we have here, and then we'll apply the gira on it, and we have this. And here we have something to set. I'm gonna back to this part, but the data that we have here for every cluster came from these numbers. These numbers is the exact numbers that we have. That's it's based on every module that we have. For example, if we have something, for example, if we have any force flow here, and the number and the parameter that we have in closing or opening this gira, the different angles that we have here is based on that numbers and that zone in this module. And another thing that we have to set this gira is the minimum and the maximum of each parameter. I think it's how to define that. What is the minimum and the maximum of how the module can be open or the gira can be open or closed more. And please pay attention to this point that these numbers that we have here, all of them, the file that's Behnaz have sent it to you, it's exactly that's should not be less than it or more than it. We can, for example, this minimum, we can have, for example, more with higher number, but we cannot change it to less than, for example, 0.53. And after we applying this gira, we have this. We have this output that it's all of the lines. It's through all of the lines transferred, converted to some beams and to some mesh that we can have this form, and we can bake it or put it to another time to bake it to have the Rhino model. But I think it's the same thing that we need, and we have applied the gira by based on the force flow and based on the regions that we have, and opening or closing the parameter based on that number and the regions that we have based on the force flow. And this part is a part that's we cleaning or we changing the force flow structure to what we need based on the regions that we need. For example, we have this force flow based on different numbers and different how can I say, different force flow that we have here, and then we need to make it something that we can handle it better and manipulate the numbers and the, for example, different range of force flow in each module. And for example, when we put the index on number, for example, 9, we can see which of those regions have this compression, for example. Or for when we change it to, for example, number 5 or index number 5, we can see that, yeah, which of these force flow we have these tensions, or the tensions are between these two numbers. And what we can how we can use it, these points these points or these lines, or these points, I think better, it's gonna be our phi serial foot that I will return back to it. That's what how we can use from these points as a foot for phi serial. I will put it on the number 2. As we mentioned earlier, the reason that we choose this region is based on that we have the -0 and +0, and the changing the different force flow in this region, and that's the point that we choose this region for empowering these cross sections or that elements. Okay, it's the first part that we can have this input from it or output from it, and we have these points as a foot for phi serial. We'll go for phi serial, and again we can define a new surface for it. You can see that the previous surface, that it was gray surface, you can see it in gray color, and the purple one is the new surface that I've defined for it, just for making sure that we have some intersections between the phi stereo workspace with our grid. And if I, for example, define this surface, the same surface for phi stereo, the workspace will limit it to just under the surface, and it's not something that I need. Okay, I will hide this. As I said before, this, for example, this gray one is for Rhino files. Here we can change the size of the work cell. I think 0.15 is something that's suitable for this. For the things that we're gonna do, we can make it, I think, more than this and even less than this. But the things that you should keep in your mind, that please put it between 150,000 or 200,000 work cells is enough for this case. And then we should go for defining a workspace. The workspace that we need is based on something that we have here. It's, for example, is in this case, it is our workspace. How to define this? As I said before, for example, we need, for example, 2 walls here. For example, these 2 curves are my lines. I define some boxes or extrusion for this just to make sure that I have subtracted some boxes or some extrusion from the workspace just to have a just to limit it, the workspace for Physario. And I can put some limitation for Physario that don't go to that points. It is on my space, not yours. And we can define the boxes here. And let me just something as a side note. For example, here you can see that I, for example, choose this edge and just move it a bit, and it's not, you can see it's not in the same level of the lower one, just to make sure that I have a suitable space here for linking between different foods. I will explain it more for you, but just keep in mind that we need somewhere to change this extrusion to have a better outputs. And then is the stage, or this is the phase that we need to define our food, or define the food for Physario. You can see the force flow that I have from Karamba, that I have it here. We have some environmental analysis here that came from Ladybug. As I said before, it's just an example. Do not you must not just use this. You can have a lot of options. For example, different data flows that you need to define for your projects or your research objectives. And the base points, that is something crucial for every output that we need for this Physario. That you can see that we have it here. The points that I've mentioned earlier, for example, the link between these two. For example, if I return, for example, if I put it in this style, you can see that the link between these two different foods, we will cut it, and it's the Physario. For example, the Physario should go this way to connect this Physario and these work cells. So for control it better, I just when my freeform is something that's it's not a freeform, and we have a lot of options. I think the best option now is to make it just by a manual model here. And in this case, I have another lines that it's gonna be our walls. Something that I've mentioned in my presentation when I was talking about how we can work with nuclear and Physario. I said that you can define different voxels and different attractors for it. You can see here that what I have done here, because, for example, these points as a walls is something that's less important for me. I put it in other voxels and make the maximum range, for example, in I think 0.005, or it's less than, I think it's gonna be 5 millimeters. It's the maximum range that can choose or find the voxels around it. And we have here, for example, something that's more important for us, the base points and the environmental that we have here. I've chosen another voxels for it. And here for example, even I can, for example, have a lower multiplier for it, or here I can define as a food for different foods for it. For example, in your file, you just have this one. But in this case that I've done today, I added a new voxels or new foods voxels. And as you can see here, we can, for example, here insert some additional parameters to have more and different voxels from anywhere, just to union all of them, or how can I say, yeah, union all of the voxels together. And after that, I set all the foods, I think, correctly. Just keep in mind, maybe you should have a lot of iterations to have what's the best proportion for your project, to what have your mind. For example, for this one, I've changed some of the setting and some of the, for example, the value of the maximum range or even the multiplier, and to find the best setting for my tractors for finding the foods. And yeah, we have here, you can see it here, that it's the union between our base points, our environmental data flows, and our walls, and our main workspace. Just to keep in mind that we should have I think, a reasonable or rational space between this line with these boxes to have that Phycerium can go for it. When we narrow it a lot, maybe the Phycerium will ignore it because there isn't a lot of voxels to go for it. And for Phycerium, it's important to have a good space or suitable space to go for more foods. And then we can hide this one, or yeah, here I can turn this one and just turn this. And let me do something. Turn this one ready. Here, yeah, we have this one. We have the output from the graph, and we will see how Phycerium go for every point. Yeah, and this one is the food points that you have, and you can see that how Phycerium go for this food. Maybe, I don't know, maybe we should change some of this setting. For example, as I remember when I was setting this setting for this case, I've changed this deposit just to have a better outputs. Just make sure that speed and the trail size is something that maybe affect your project a lot, but these kind of things, other one, you can change it more. And we can go for another Phycerium, make sure to add this on, and we can go for it. After 50 iteration, I will pause it to see what Phycerium has done. I think it's reasonable now. I think it's reasonable. Okay, you can see the link to the. I think you can remember that I said that when we have some walls near to our base points, you can see that it's gonna make it integrated, and we will have some combination between these two. And you can see these will have no work. Yeah, everything is okay. After we have everything is okay, we can close off this preview and go for convert it to a mesh, because the mesh is the things that we need for it. We have different settings here for mesh. For example, you can see that some irrational meshes here. For example, we have a higher iteration for smoothing it. Yeah, you can see that we do not have that part of mesh. If you need more smooth one, you can, for example, go for higher numbering. And even you can change the point radius because it's based on, you can see that it's based on these points that we have here, is the points that we have now. And it will change these points to some meshes that we have here, yeah, these points. And you can set everything up from here, for example. It's because this voxel size should not be more than this. For example, yeah, you can see something with more details, and even, for example, it didn't ignore these points. That's something that I want. I think that was suitable for us. Sorry, guys. No, I think this one is something that's suitable for us. Now we can see a combination between the Gira structure and the Viserium. Yeah, I think if you have any question from this part, or even sharing your ideas, if you have any question, we can go for it after Behnaz explanation about the how you should present your project. Do not forget your question. Please jot it down and then ask it when we are discussing just about your projects, your questions, and to wrap everything up. Thank you very much.
Thank you so much. That was an impeccable timing. You finished on exact timing we had. So I will present to you a layout I designed. And again, thank you, Ahmed. That was amazing. So do you have my screen? Yeah, I guess you have it now. Okay, I have prepared a final sheet. It's not final, but I will work on it for a few days and give you the final form. As you can see, we have the names, the logo, and this part is the specific, explanation about your design. If you want, we can give you, a context about the workshop. But if you have any specific points about your own design, you can add it here. Also, this part is dedicated to your picture and your name. We will love to have you in this final presentation. And this is a step-by-step diagram, 3 steps from first cluster, 3 steps from second cluster. That is depending on your workflow. If you're going through exactly like us, this will be the final form, but I advise you to take one step further in each cluster, or add your own research object into it, or get creative, and this is your part. And this two picture will be containing your gray fabrication details and Fusarium fabrication details, and you can change this a bit later if you want, and this will be the designated part for your final amazing marvelous renders, and a few explanation about your concept and what inspired you. I mean, and what you know, you will have a specific research object. For example, we talk about a few ideas, yeah, about what you could do with this parts, and what you can add to this workflow. You can explain it here. And this is created in InDesign, but of course, I will share it with you in a few days. You will get, you can download this from our Google Drive, but just in case, if you have a problem with InDesign, you can also use Illustrator or Photoshop. Feel free to use whichever you are comfortable with, or even if you have some problem, please don't hesitate to ask. I will guide you through it. And what else would wanted to add? So far, this is, yeah, this is so far as we're gonna need, but keep in mind this will be the final sheet your group will be submitted for the finals, and that's it. Okay. Did I miss any point, or do you have any specific point to want to add, dear Ahmed or dear Selda or Mr. Fad? Okay, nothing? Okay. So based on our agenda, we will go through your ideas and your work. Is that good? I think we're gonna stop live stream, so anyone can feel free to share their ideas without feeling any feeling shy or anything. Your mic is off. Still is off.
Yeah, I think, do you want to close the YouTube streaming? I think maybe some people or some of our guys that are out of this session and they cannot be here, maybe they need to see the uh, guys presentation and guys idea. Maybe, well, I don't know. If you want, I can stop it. It's okay. Yeah, I think Mr. Fad is something that older than 60, I think.
Guys, any of you want to join our discussion live? Maybe just discussing your ideas. Yeah, no worries, Mustafa. It's actually a good starting point because we went through many different applications in Grasshopper, and how to see it, in the many different aspects on, from perspective